I hope you are doing well wherever you are. Welcome back. We continue from where we left last time. Last time we had a question on the periodic table. Remember, I taught you on how to draw your own periodic table in a way that in case in future you get a periodic table that has issues, that has mistakes, you'll be in a position to tell. And if you are able, you even request for a correction from your teacher. So a normal periodic table should have 8 groups, and for the first 20 elements we only consider 4 periods. So last time we had 2 questions. Today we continue with a few more. Question 3 reads, an element J has atomic number 15. Indicate with a tick on the part of the periodic table the position of element J. Remember from our previous lesson, we already said that the letters that will be used in this question are not the actual symbols for those elements. So I want us to begin, and this is where we should start. So on the grid, that is the periodic table that has been provided, we are supposed to write numbers, and last time I shown you we are supposed to begin with number 1 there. Then on the other side we have number 2. We come back this side, we have number 3, then number 4. We go ahead with number 5, number 6, 7, 8, 9, 10. We go back this side, 11, 12, 13, 14, 15, 16, 17, and 18, then 19, 20. If you watched our previous video, you will learn that in between here, on this area that is shaded, we say that this one contains the transition elements or the transition metals. And in the process we also said that this space is usually divided into 10 columns. So meaning from this number 20, by the time we are reaching this space, we will have 20 plus these 10 columns. So it will be 20 plus this 10, and then meaning this one will be atomic number 31. Then we have that 2, that 3, that 4, that 5, and then that 6 on the far end. So this is just a recap of what we did last time. So today I want us to add something different about the different elements, and we put them in the spaces that we have been given. So element number 1 is usually hydrogen. Then we go to helium, then lithium, then beryllium, then boron, then carbon, then nitrogen, then oxygen, then fluorine, then neon. I hope you can see. Then sodium, then magnesium, then aluminum, then silicon, then phosphorus, then sulfur, then chlorine, then argon, then potassium, and then finally for the first 20 elements we have carbon. So I hope you can see, and I hope you have that mnemonic that I talked about last time that you use when you are trying to remember all of them in the order that they are in. So remember question 3. We have an element J. J is not the actual symbol, as you shall just see. And this element J has an atomic number 15, and we are supposed to indicate the position of that element on the grid or on the periodic table provided using a tick. So we put a tick where the position of element J is. So going with the numbers that we have already indicated, we are supposed to go direct to where we have number 15, and then as directed in the question, we put a tick. So the place where the mark will be given from is if you put a tick on the periodic table provided. And last time I told you that the periodic table is usually referred to as the grid in some of the questions. So either you are told it is a periodic table or you are told it is a grid, both names fit when you're dealing with such kind of questions. So you use a tick. So if you put any other mark other than the tick that was provided in the question, no mark will be given. Some of the students make a mistake of putting a tick at the end of the question. They are usually given a 0 because the question was using a tick you indicate the position of that element J on the periodic table. So whoever will be marking your paper will then come to this point where we have atomic number 15, and then look if you have indicated the position of element J using a tick. Remember what I have just said. In the question, there is this instruction that is always provided that says that any element that is used in this question is not the actual symbol for that element. And we have just proved that now that in the question it was known as element J, but on the grid it is actually phosphorus. In the questions that will come in the near future, note this also. In case you are told to write a chemical equation and you are told to use any element that has been provided, and when I say the elements that have been provided, I mean like for this case where we have capital H, capital M, capital L, capital N, capital K, capital P, if any of those elements that were provided for in the question, if you are told to use any of them in the writing of a well-balanced chemical equation, you use them as they are. Do not try to identify the real name or the real chemical symbol for that element. Use the letters that have been provided for you on the grid. Then, question 4. We are supposed to select an element which can form an ion with a charge of +3, +1, -1, and -2. So while we are doing this question, there are a number of things that you are supposed to remember. And there are these two terms, cations and anions. Cations are usually positively charged ions, and anions are negatively charged ions. For anions, in this case, as they have been shown in the question, the charges for those elements, we are supposed to note this. Cations usually come from metals. Cations usually come from metals, and when they come from metals, it means that metals are the ones that react by losing electrons. They usually lose electrons when they are reacting. Anions usually come from nonmetals, and it means that when you're dealing with nonmetals, they usually react by gaining electrons. What makes metals to have a positively charged, to have a positive charge? Let me say it again. The question is here, what makes metals to have a positive charge yet they are losing electrons? I believe this one we shall do in the next lesson, but let me just say this. The reason as to why we have metals becoming positively charged yet they are losing electrons is because when they lose electrons, they end up with extra positive charges. Because for this case, electrons are negatively charged, and then we have the protons that are usually positively charged. And the number of protons and the number of electrons for any atom, they are supposed to be equal. The number of electrons and the number of protons for any given atom, they are supposed to be equal. And when they are equal, that is the reason as to why we have atoms becoming electrically neutral. Atoms are electrically neutral because the number of electrons and the number of protons are usually the same, they are equal. So meaning, for a metal, now that the electrons and the protons were equal, if a metal loses an electron, either one or many, it means now that the total number of both were equal, it means metals will have lesser electrons, the negatives, and so there will be extra positives on the metal at the end of it all, at the end of the reaction. So metals end up with extra positive charges. When we go to the nonmetals react by gaining electrons. The same happens. The number of electrons, even for nonmetals, the number of electrons and the number of protons are usually the same. But if, so when nanometals gain, and they are gaining some negatives for the electrons, it means they will end up with extra electrons, extra negatives that will be more than the positives, that will be more than the protons for nanometals. So in our next lesson, I'll be guiding you more on the ion formation, because that is what explains better what will be happening. So for this question, where we are being told to select an element from the grid that has an overall charge of +3, already you know that for these two, they are already metals. They are metals, these two. They are metals. And these two are nonmetals. These two are nonmetals. So that is the first interpretation that we have just made. That when you just see a positive charge, another positive charge, just know these are two metals. Because metals are the ones that react by losing electrons, meaning that they will have extra positive charges. If you see in any element with a negative charge, it means that one is a nonmetal. It got the negative charges from the fact that it reacts by gaining electrons. So it will have more electrons than the protons. So meaning, now that these are two metals, it means the one that will be losing 3 electrons, so acquiring a charge of +3, it must be in group 3. This one is in group 1. So remember from our previous lesson, I told you of how you are supposed to write the number of the group. So that is group 1, group 2. Then here we have group 3, group 4, group 5, group 6, group 7, and group 8. So the element that has a +3, meaning it is a metal that will have lost 3 electrons, is actually element L. So we go down here and we say that this one is element L. The one that will have lost only 1 electron from the grid, we have either you write it as capital H or you write it as M, because either of them is in group 1, and in group 1 metals react by losing only 1 electron. So there you have two answers, either capital H or capital M. Either capital H or capital M. On the side of nonmetals, this one that has a charge of -1, it means that it reacts by gaining 1 electron. So if it is gaining 1 electron to become stable, it means then it is in group 7. It then means it is in group 7, and if it is in group 7, the answer must be P. So this one with a -1 is element P. This one with a -2, it must be in group 6, because elements in group 6 are the ones that requires to gain 2 electrons to become stable. So there we have element K. Element K. So let me conclude this by saying, this. For you to understand whether metals have a positive charge and non-metals, if they have a negative charge, you just need to know that any element can either gain or lose when it is reacting. And the gaining or the losing, it is to make that element become stable. Becoming stable means to acquire the stable configuration. And we usually have 2 types of stable configurations. We have either a stable configuration of 2 or a stable configuration of 8. And when I say 2 and 8, it is the number of electrons that will be left in the outermost energy level. So if an element will have lost or gained and it end up with 2 electrons in the outermost energy level, it will acquire a stable configuration that we call a duplet. A duplet configuration. This is the spelling of the word duplet. That is to mean that the element has acquired a stable configuration with 2 electrons in the outermost energy level. And a good example is lithium. This lithium is atomic number 3. When it is atomic number 3, it means being a metal, it will lose 1 electron. It will lose 1 electron. Let me write here. And I give you an example of lithium so that you understand better. Lithium is atomic number 3. So the electronic configuration for lithium is 2.1. Remember, lithium is in group 1. And group 1, let me say this NB here. Elements of group 1, group 2, and group 3. Elements of group 1, group 2, and group 3 are metals. So remember that. So lithium being in group 1, you know it is in group 1 by checking the number of electrons in the outermost energy level. So lithium having only 1 electron in the outermost energy level, it means it is in group 1. And remember, I have just said earlier on that metals usually react by losing electrons. So lithium will lose 1, and when it loses 1, when it loses 1, it will end up with just 2. So I have just said that if after losing an element acquires 2 electrons in the outermost energy level, so for lithium it will be left with just 2 after losing the 1. This kind of a stable configuration is the one that we are calling a duplet configuration. So I hope now you understand what it means. Let me give another example of another element that we call sodium. Sodium has atomic number 11. So atomic number 11, so with an electron configuration of 2.8.1. When it loses the 1, it will end up with 2.8. You see this 8 that will be left in the outermost energy level. That is the other stable configuration that we call octet. This is an octet kind of a configuration. So we usually have 2 types of stable configurations. Either the duplet configuration, that one is stable with the 2 like that one of helium. Because you check here where we have group 8. These elements in group 8, they are already with a stable configuration. Look at helium, it already has 2. This one has 10. When you write the electronic configuration, it will be 2.8. So it has the octet. If you check on argon, when you write the electron configuration, it will be 2.8.8. Again, the outermost energy level is already full with 8. So helium usually has a duplet configuration, and these 2 usually has an octet configuration. Helium has a duplet configuration. Neon, argon, and the rest of them down there, the likes of xenon, the krypton, they usually have an octet configuration. So when metals lose electrons, like lithium, and it ends up with 2, these 2 looks like the electronic configuration for helium. It means lithium has acquired a duplet configuration like that one of helium. For the rest, the likes of sodium in group 1, the likes of potassium, which will also have 1 in the outermost energy level, and once it loses the 1, it will have 8 in the outermost energy level. It will also on the other side have an octet configuration. So I hope you have understood something. So in our next video, I'll be explaining more on ion formation, just in case it has some difficulty for you to understand. So meanwhile, make sure that in the comment section you are asking questions, telling me where I should clarify, and I hope by the end of it all it will be too easy for you to understand. If you have not yet subscribed, I request that you do so, because by doing so you'll make me be in a position to reach very many more students like you. Thank you. If you're a parent, make sure that you give your child a chance to watch these videos. They'll be of very great help. So make sure that each and every time you watch, you are also writing, because the simple notes that you make from what you understand, they will be of great help in the near future. So have a nice evening. May we have a good time even as we continue with our holiday. God bless you.